Hello and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. When ML teams try to run complex workflows through traditional orchestration tools, they hit walls. Cash App discovered this with their fraud detection models. They needed flexible compute, isolated environments, and seamless data exchange between workflows, but their existing tools couldn't deliver. That's why Cash App relies on Prefect. Now their ML workflows run on whatever infrastructure each model needs across Google Cloud, AWS, and Databricks. Custom packages stay isolated. Model outputs flow seamlessly between workflows. Companies like Whoop and 1Password also trust Prefect for their critical workflows, but Prefect didn't stop there. They just launched Fast MCP, production-ready infrastructure for AI tools. You get Prefect's orchestration plus instant OAuth, serverless scaling, and blazing fast Python execution. Deploy your AI tools once, connect to Claude, Cursor, or any MCP client. No more building auth flows or managing servers. Prefect orchestrates your ML pipeline. FastMCP handles your AI tool infrastructure. See what Prefect and FastMCP can do for your AI workflows at aiengineeringpodcast.com/prefect today. Unlock the full potential of your AI workloads with a seamless and composable data infrastructure. Bruin is an open-source framework that streamlines integration from the command line, allowing you to focus on what matters most, building intelligent systems. Write Python code for your business logic and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. With native support for ML and AI workloads, Bruin empowers data teams to deliver faster, more reliable, and scalable AI solutions. Harness Bruin's connectors for hundreds of platforms, including popular machine learning frameworks like TensorFlow and PyTorch. Build end-to-end AI workflows that integrate seamlessly with your existing tech stack. Join the ranks of forward-thinking organizations that are revolutionizing their data engineering with Bruin. Get started today at aiengineeringpodcast.com/Bruin, and for dbt Cloud customers, enjoy a $1,000 credit to migrate to Bruin Cloud. Your host is Tobias Macy, and today I'm interviewing Craig McLuckie about improving the security of your AI agents through curated and optimized MCP deployments. So, Craig, can you start by introducing yourself?
Yeah, hey, thanks for having me on. I'm Craig. I'm the founder and CEO of Stacklok. Previously, my sort of background is entirely in the distributed systems and enterprise software domain. So I worked at Google, where I was responsible for bootstrapping and shipping Google Compute Engine. I then had the opportunity to look beyond and came up with the idea for Kubernetes with a couple of other co-founders of the project. That obviously worked out pretty well. I started the Cloud Native Computing Foundation as a spiritual home for Kubernetes and other open source projects. And then I'm currently on my second company. So I worked a lot in the kind of relatively traditional distributed system space. And at Stacklok, we became really interested in AI as a sort of disruptive moment, sort of this epoch boundary. And so we started really focusing on what we knew, which is the integration and the sort of interfaces between existing systems and these new assistive and agentic technologies. And it's great to be on your show.
And do you remember how you first got started working in the ML and AI space?
Yeah, I mean, it's interesting. And for me, it was, the sort of journey of fascination and increasing kind of interest, right? Like, I think we all had this moment when ChatGPT was released and it was like, wow, this is just a wholly different class of system. And it's fascinating, and started playing with it as a curiosity. And I think I was an AI denialist for quite some time, right? I think a lot of people probably were, where I think a lot of folks, certainly me, I'm an old kind of school distributed systems guy. I imagined that it was going to be asymptotically convergent on a set of capabilities that would make it interesting and a curiosity in certain domains. And then we'd start to see it emerge as this kind of new class of system that you could use to augment what you were already building. And I think, as my own use of the technology started to emerge as just, in day-to-day use, initially around just research-based functions, but then increasingly as I wanted to do things that I didn't want to bother my engineers with, that it would enable me to actually start writing code, it became clear that I was deeply undervaluing the impact that this really was, this kind of epoch-defining moment. I think every epoch of humanity is kind of defined by its dominant technology, right? The Stone Age, the Iron Age, the Digital Age. And I do think, it became clear to me that we were entering into the space. And for me, it was interesting because, we started this company around a certain supposition, this idea that 80% of the world's software, historically has been written by random people on the internet. So, open source libraries are this staple. And I started Stacklok as a way to start, just helping build this bridge between, the way that people are consuming software and the communities that are producing it. And I think the journey for me as a sort of AI maximalist and building an AI maximalist company really started when I have asked myself, are my assumptions for this company still going to be true in 5 years, right? Like, and are they going to be true in two ways? Are they going to be true in terms of, are people still building software the same way, right? Like, are they still using the same SDLC that they've always used? Or is the role of the developer going to change? And then the second piece was, is the open source ecosystem that powers this going to be consumed via package managers? Or is it increasingly going to be consumed by a lot of that knowledge being parameterized and then being used to actually render up entirely optimal expressions of what you want? And it was clear that like the disruption that this represented is profound. And I think a lot of people that are, like I was pretty involved in what we call the kind of cloud native disruption, like this sort of transition from, building, relatively simplistic, relatively complex, but simply described vertically integrated apps to kind of using things like Kubernetes, and this felt every bit as significant, in fact far more significant than that. And so that moment of realization really drove me to start looking at where to create value in this ecosystem. And I would say that moment was defined by my own experiences with AI, but then also this recognition of the profundity of disruption that it represented.
And one of the standout aspects of that knowledge curation and knowledge delivery aspect of the, I guess we can call it agentic revolution, for lack of a better term right now, is the model context protocol. And that has become broadly implemented and in some cases broadly adopted, though the adoption is maybe a bit unequal. And I'm wondering if you could just talk to some of the ways that you're seeing that as an exemplar of this new way of thinking about system design, application delivery, and the ramifications that it has on the development and delivery of software.
Yeah, I think kind of MCP is interesting, and the best analog I can come up with, like I always think back to my own lived experiences, and I remember the first time I saw Docker, which was I don't know how familiar this audience is with Docker, but it was a technology that enabled you to kind of package up an application into a reusable entity and ship it and run it in any environment. And it was this kind of moment, right? Like, wow, we now have the ability to unlock portability, and we've created this lightning in a bottle moment, which redefines the developer experience. It just changed the way that people worked. And I think MCP it's very similar to that, right? Like it's the beauty of what was produced was this incredibly simple specification that described a way whereby you could translate, this ocean of API and data and everything that existed in the world's distributed systems into a natural language format that was sort of optimally consumable for models. It was just this very, very simple and elegant way to start describing it. And so, as I've looked at this, obviously the protocol is constantly evolving. But I think if you kind of cut to the chase, like what does this actually mean in its most fundamental terms is this is a gateway to building AI native apps and AI native experiences, right? Like, we've looked at a lot, I speak to a lot of enterprise organizations, and, a lot of folks are working on this idea of like, hey, can we we really do two things at the same time, right? Like people are trying to do two things concurrently. One is, can we use AI to enable us to go faster? Can we enable AI to let us, do the work that we're doing today in a sort of in a much better space? And then the second thing they're trying to do is, can we build out these competencies that allow us to be future-proof, right? That allow us to be able to start, kind of delivering, outcomes over time and outcompete our competition. And it's interesting to see the tension there because, the first thing often says like, hey, just go buy a vertically integrated AI application. And then the second thing says, hey, you actually have to start reasoning about this from a platform builder's perspective and think about what you need to do. And those two things are in tension. I think MCP is this beautiful technology that enables you to start spanning that. And what it leads to is the ability to build AI native applications. Like a lot of these applications that are being built today that are sort of wildly successful and being consumed at a furious rate because they bring value engineering. They actually solve the problem of rendering context in a way that models can understand to create business value. Feel a little bit like the horseless carriages. I'm not the first person to say this. I think VCs have been saying this for a while. But when the automotive industry started, when the internal combustion engine emerged, people just put that onto a carriage, and it was a horseless carriage, right? Like it was not a modern automobile by any stretch of the imagination. And I think AI native apps mean that people are interacting with a model in a multimodal form factor. And right now, when we say multimodality, people often think, hey, it's voice, it's image, it's video, it's whatever. But multimodality could also be rendered UI. Like there's some things when you want to be able to see a calendar, you don't want something in plain text describing a calendar. You just want to see a calendar, right? Maybe you want to click the calendar. Maybe you want to move things around. And so as we look to where app development and app architectures are going, the model becomes the presentation and view model for modern apps, which then raises the question, well, how, if you're building an application today and you're building a web application, the API is the interface between your presentation layer and the kind of backend systems where you kind of organize logic and you do all of that. And so I really think that MCP is the API for AI native applications. And it's going to herald a whole new class of experience where you no longer have to have a bunch of vertically integrated apps where you're constantly context shifting between them. And it will offer up two things. One is the ability to establish and share context if you do need different experiences, but more importantly, to be able to start to establish the model as your working area. This is the place where you do your work. It renders things up in a variety of different form factors. You could call that the browser for AI-enabled applications. And it means that you will see developers starting to think not about, how do I actually create this kind of vertically integrated story? It's really, how do I start to think about organizing workflows? What are the nouns and verbs associated with the things that I need to do? How do I express those in a way that, something that's already powered on natural language, and increasingly some of these other concepts that will start to show up in the protocol can consume it in a meaningful way and create a great experience. And then, oh, by the way, I also have to do all of the details around authentication, authorization, observability, and all the other things that come with building applications. But I think that is the most fundamental transition that's going to happen.
And in that context of MCP, there are a variety of different frameworks and implementations around it. The protocol itself has gone through a few revisions, most notably going from not having any concept of authentication or authorization to it actually now being well integrated into the specification. And I'm just curious if you can talk to some of the ways that you're seeing people approach the overall exploration and adoption of MCP, and then going from, hey, this seems like a useful little tool, to, oh, this is actually going to be a substantial benefit to me, my team, my organization, and now I need to actually get it into production, and just some of the, I guess, misconceptions or stumbling blocks that folks run into along that evaluation path.
Yeah, I mean, there's a lot of ground to cover there, but I would say the starting point for a lot of people is, holy crow, this thing demos really well, right? Like it's there's an upstream, like the way I see a lot of folks, maybe I can just describe the sort of the canonical journey for a lot of folks, right? Like the starting point's often like, hey, I'm using Cursor and I want to integrate something else. There's probably a tool for that, right? And there's a sort of incredible burgeoning numbers of tools that can be used. And the starting point for a lot of people was like, hey, I'm using an assistant technology. I want to integrate it to something else. I can just run this thing locally. I can just go fetch this thing from a package repo up there. I effectively allow, Cursor, Copilot, whatever, to npx run this package. And then I just provide that package a set of credentials, because now the auth is a part of the flow. And that package that I'm running is now able to access a lot of these services, and it'll do the mapping for me. And that's great, right? Like it's really exciting. It's also absolutely terrifying, right? If you actually think about just take a moment to think about that, right? Like, don't get me wrong, I'm a huge proponent of this technology, and I think that there's so much potential with it. But I think it's also important to recognize this one truth, right? I can't remember the exact statistics, but there are, I think at the moment, something like many thousand malicious MCP packages out there. And you're basically, kind of giving a lot of your, we're giving up a lot of common sense in terms of how we start to run these things. For real world enterprise organizations that are starting to look to deploy these technologies, the sad truth is that the rate of MCP based exploits is growing at a pace that is outpacing AI spend. Right, almost 20% of organizations that have embraced MCP have had some kind of exploit from it. Right, so starting with this idea that yes, you can npx run something, people do that, and it creates a tremendous amount of value, but it also is exposing you to a lot of risks. So people will be like, okay, let's not do that. So the next logical point is, hey, this is great. We need some kind of hardened surface so that we know this thing can be trusted. So the next consumption pattern tends to be what I think of as SaaS-based integrations, right? So when we're increasingly seeing a lot of this, where, hey, you have a SaaS-based system that you want to use, and now I need to be able to connect that SaaS-based system to this thing. And hey, conveniently, a lot of them are now starting to expose MCP-based endpoints. They're actually doing the work on the SaaS side to start reasoning about how to transform their API into these basic primitives that can be operationalized, and that addresses some of the problems. Like it certainly solves for the problem of the malicious MCP package and getting hurt and having to reason about it. And what it does do is it starts to give you a very kind of nicely normalized set of interfaces that you can do, and you can get a certain kind of path down the journey. The thing that I see a lot of organizations and developers stumbling with is like, okay, well, that's great, but like, how do I start to expose my data? Right? Like it's that transition from, there's all these kind of SaaS integrations that are available, they're consumable. How do I expose my data specifically? And how do I start mixing my data into the tool set that people are using? And that's kind of problem one. And I think problem two is, what people are starting to realize is tool pollution is a real thing, right? Like it's context windows are finite, input tokens cost money. If you go and turn on one of these servers, you are going to burn a lot of tokens, right? Like the GitHub server, we sort of saw this evolution where it kind of grew to about 110 tools. And then GitHub really started thinking like hard and seriously about how to kind of optimize the set of tool interfaces, for the specific workflows that developers are doing, so that the tool count kind of came down. We've seen some diminishment, but you're still probably adding something like 10,000 input tokens by just turning on that server. And so, once you start to get to a point where you have a lot of tools, the selectivity becomes a problem, right? Like it's like, hey, I have to actually start manually turning them on and off. I have to reason about when I want them. And so that problem around, adding, semantic search and sort of semantic awareness. And we're seeing, some systems start to implement this. Like, Anthropic recently added their own semantic search, like search to tools, so you could start to aggregate them and not have to, have all of those input tokens in every window. But yeah, like the next point that people start to hit on that journey is, how do I expose my data, and then how do I actually make this halfway sustainable? So I'm not just burning a tremendous number of tokens. And then I think the sort of step that happens after that, and I'm happy to provide an example of this, is how do I start mapping this to my actual workflow? Like, what are the nouns and verbs that I care about, right? Like like I'll give you an example. A recruiter, like I manage a recruiter, and he lives in basically 4 tools. I mean, there's a couple of others he uses, but for simplicity's sake, we just describe it as 4 tools. He uses the Google Productivity Suite, so Gmail and Docs. He uses Greenhouse for candidate management. He uses LinkedIn, and he uses Calendly to schedule interviews. Now, he can get to a certain point by just integrating those systems into his work, right? So he can integrate LinkedIn and integrate this and integrate that and integrate these pieces. But there's still some amount of context shifting. Like, candidate does not mean anything in a normalized way in that system, right? Job description is a relatively open-ended thing. But by looking at his workflow and starting to describe the things that he does, like, hey, I need to source a candidate. What does that mean? What is our process here? How do I start to describe that as part of the tool itself? How do I start moving from, like, I want to write a job description. Well, that's great. There's already a template, but do I have to go and describe, use the template to do this? Or can I start to write a job description as a tool that basically, like, here's the base, here's the base thing, here's the transcript of the interviews that I'm using. Let's kind of, start to kind of organize the structure of that around the work that the person's actually doing. And so I think of that as the logical destination where we need to get to, where it's not just about a set of, vanilla interfaces where you're putting a lot of cognitive load on the model. And all of the payload that's being kind of expressed there is relatively abstract. It's relatively generic, but actually starting to become much more precise through the use of tuned tool descriptions, through the use of specific tool-based workflows to actually start fitting the work to the person that's driving it.
On that point of the selection and evaluation of the tools that are exposed in these various servers, using GitHub as an example, it can be very manual to understand which tool does the thing that you actually care about for a given workflow. And to your point, I don't want to have to deal with toggling them on and off every time I want to do something different. And I'm curious how you're, in particular in the project that you're building with ToolHive, thinking about that workflow of being able to define the tasks that you want to do, map that to the tool selection within these various servers. And I know that in ToolHive, you, for instance, have a way of building a composite server that exposes all the tools from multiple backing servers, and just how that tool selection and context optimization workflow looks for somebody who is starting to figure out what are the things that I want to be able to do and what are the pieces of information that I need for those different workflows.
No, I mean, I tend to take a somewhat, I don't know, like I'm sure the audience is, like a lot of folks have read the paper, The Bitter Lesson, right? And I take a somewhat reductionist view on what really works out there right now. And the answer to what really works well right now is frontier models plus great tools create great results, right? But you have to start really thinking about what a great tool is. And so I think there's a number of different steps in this regard. Tool selection is hard, right? Like, and there is an art to describing a tool so that it is actually invoked in a specific context. There are a set of things you can do like right out of the gate. So, for instance, what we started, with ToolHive right out of the gate was just adding semantic search into the call path, right? So, and we did a bunch of analysis around this. So we basically picked a bunch of the most popular tools out there. We described, we generated a big baseline of synthetic kind of data. And then we just started running evals, against, query should map to this tool, are the various models being effective in tool selection? And it was kind of interesting because, when you look at the corpus of servers that are published, these are just generic servers out there. We see frontier models like the best of the best right now, based on our heuristics, achieving about a 93 to 94% selection rate. So 93% of the time when you have a query which maps to a tool, those models will select the tool. Interestingly enough, if you're in the business of using smaller models, like less heroic models that, because inferencing cost is expensive, or you really care about the latency of these queries, if you're trying to do something in more real time, the performance of those systems degrades very quickly, right? So when you move from a frontier model to like a sort of, a cheap and cheerful SLM, tool selectivity falls off to something like 34%, based on our heuristics. And so as a starting point, just putting a semantic search capability in front of these. So instead of basically saying, hey, here's a flat set of tools, pick one, saying find tool, and basically being very careful and spending a lot of time, building a very accurate tool description, which is, this is the endpoint that you call every time to blah, 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 whatever the sort of description of the tool that generated models hitting this point, and then delivering top K, like the top 6 tools, allowed us to achieve very high rates of tool selectivity across every model class. So we were able to get to a point where a much more modest model could achieve the same level of tool selection for a given task. But even in that case, you're still sitting at at best case scenario, about 93% of the time, the actual tool will be mapped to the task that you're handling. And so this is where evals come in, right? Like this is one of the most, I think, significant points about operating with these classes of systems, right? Like when you go back to the world of old school distributed systems, proof of correctness was the unit test. And the unit test, you get the thing to run. And if you have enough test coverage, you can be pretty confident that you built the thing that works. These are stochastic systems. Like you're dealing with probability intervals and boundaries, right? And so you have to start with an eval. You have to start with an eval framework. Right? So if you're a sort of generalist user just using these for convenience sakes, like 93% tool selectivity, that's fine. Like I just redo it and occasionally it falls down and irritates me. I burn a few tokens, but no worries. But if you're serious and you're trying to build an agentic system that is performing a task, you have to see the whole loop, and it has to start with evals. And so, one of the things that we always encourage people to do is like, hey, you want to start building tools, like what is your eval framework? Like, have you got that set up? Like, what are the set of queries that should actually result in just starting with tool selection look like? And then, can you start to set up an evaluation cycle so you can start to tune your tool description to match the task so that the tool is selected? And then once the tool is selected, can you start to tune the payload so that the task is completed, right? So you have to start doing this kind of deconstructionist way of looking at it. So the second thing that we sort of tend to recommend when people are walking on this journey is run an eval framework. We're actually working on one. We'll ship it momentarily so that people have a nicely integrated eval system as part of the ToolHive platform. And then, the question becomes one of like, how do you start to actually structure workflows, right? You both want to do two things. You want to kind of optimize the context, and I think of it as context real estate management. You want to load that context window up with, precisely the right information so that it can start to perform well. And it's interesting because that's not always obvious, right? So like, let me give you an example. Like if you're working in the sort of geospace, if you're building a GIS enabled application and you say feature, that means something very specific, right? It's a collection of vectors that describe an entity that actually exists in physical reality on the terrain. If you're a developer and you say feature, you mean, hey, it's an atom of work that I'm using, right? So there has to be this kind of contextual awareness where the tools that you're building have enough additional metadata to start describing the thing that they're presenting, so that it's actually, when you're inferencing against that thing, it's actually generating the right results. And so that process of building tools becomes relatively complex. And I think there's really kind of three things. Like one is getting the right nouns and verbs and optimally describing them. Two is starting to reason about workflow, right? Like it makes sense to start to think about, workflow associated with something and being able to, represent an orchestrated set of actions that generates an optimally, rendered view. Because, by doing that in a sort of one shot with structured workflow, it's avoiding a lot of round trips. So you don't get that kind of cascading entropy that you get, when you're running a lot of sequential operations. And then the third piece of it is transactionality, right? Like, as you're starting to move from, hey, I'm just trying to build MCP servers that reason about, getting context into the context window so I can answer questions, to actually performing work. Sometimes that work needs to be committed in a sort of transactional way. So you need to start thinking about like, hey, if I'm updating, three things across two databases, how do I create a shared transactional semantic so that, if the operation fails, everything is reverted? So I'm not starting to try to debug these weird, kind of orchestration failures on the back end. And so I don't know if I'm getting too far ahead of myself here, but I think there's a lot of richness in going from, hey, I'm NPX installing off the internet and it's connecting to GitHub, using my credentials, and I'm just going, yeah, approve, I'm not really paying attention, to building a system which is unlocking like AI enabled application development with these highly optimized and highly reasoned about, views that are tuned to the specific workflow that you're trying to accomplish.
And there are a couple of directions that I want to go from here. I think one thing that you mentioned that is worth digging into a bit more is that concept of evals and the relationship to distributed systems practices where you have unit tests, but for cases where you wanted to be even more thorough in the validation and verification of those systems, you would likely reach for something like TLA plus for describing this is the way that the system is supposed to work, and running that through some mathematical proofs of the ways that it should behave in that distributed systems context. And then the idea of Jepsen tests for being able to see, okay, but how does this thing actually break when I put it into production and really put it under extreme load? And are those behaviors when it does break acceptable for the use cases that I'm planning for? And I'm wondering how you think about the ways that those two approaches map to this newer world of these orchestrated systems using MCP and context engineering and these probabilistic workflows, and just being able to understand how do we actually do something of that same degree of rigor.
Yeah, it's an interesting question, and I've thought about this a little bit. Like, look, don't get me wrong, I'm not like super deep on like formal method analysis, but here's the way that I kind of reason about this. We have this like, and I think this is a common. I find myself falling into this trap all the time, right? Like it's like I grew up in distributed systems. The first distributed system I worked on was Windows NT 351 clustering. It kind of dates me, right? Like I've been a distributed systems guy since time immemorial, and one of the things I've learned is we have this pattern where we start to kind of try to apply what we know, right? So it's like, hey, you're dealing with a stochastic system. The stochastic system is generating imperative code. I can at least reason about that imperative code, right? Like, so this is the sort of what I think of as the sort of normal sort of systems engineering thinking. And I think there's this value and veracity to that. Like, certainly these tools give us the ability to start expressing behavior in terms of formal mathematical language. It's like you suddenly have this kind of, like Amazon's been really good at this, right? Like they've hired up this kick-ass team of PhDs. They've done a bunch of formal, kind of method analysis, the stuff that was previously reserved for folks that were building flight controllers for Boeing or control systems for nuclear reactors. They've built out the muscle to start applying that to things like the S3 serving path, right? And they find some very, very subtle and very nuanced and very interesting things. And they certainly are looking at ways to kind of genericize that. I don't know what they're doing, but I have to imagine that they're looking at this, because suddenly you have the system which has PhD, they behave like a Stanford PhD, right? Like they can actually do the work to start describing these things in a formal method way. And so there are going to be classes of integrations where, like, I think there's always something that's new and in vogue, like this idea of, hey, rather than using formal MCP, just describe your sort of APIs, through a sort of JavaScript-based, sort of format, or decorate them with an open API thing. Allow the agent to vibe code something, run it in an isolated sandbox. If you really, really care about it, apply formal method analysis to it and reason about where the breakage is. But I think that's missing the point. And the thing that I come back to is these are stochastic systems, right? Like what you're doing when you're inferencing is effectively, it's a probability field, or like, I don't know, I'm sure there's AI experts that are listening in that are kind of gnashing their teeth and being angry with me because I'm probably using the wrong words. But, you've got a system that's basically, like with a frontier model, a way to think about it is it's an encapsulation of the world's public domain information, right? Like 4% of the world's knowledge is in the public domain. And I'm reasonably sure that all of that is being used to generate these frontier models, right? But 96% of it isn't in the public domain. And so, a lot of what you have to do is start to craft context that gives you the highest probability of, during inferencing, finding the logically connected set of tokens that have the lowest cosine distance from, what you want. Like it's a stochastic process. And the problem with that is that, anytime something changes, anytime you add, kind of entropy, and that could come through a lot of different ways, right? Like, I had the system set up and I was using 3 tools, and now I'm using 5 tools, and now I'm using 10 tools. And now I'm starting to put pressure on the context window. And so the self-attention mechanisms start to decay. That's something that's changed that I wasn't necessarily aware was going to change. User patterns change. People start to talk about things, new slang emerges. Like there's a lot of different sources of entropy that start to show up in these systems. And so it's not enough, or the parameterized data changes. Like you spend a whole bunch of time running evals and getting things just working. New model comes along, it's got new parametric data. What was optimized is no longer optimized. So I think there's definitely a veracity in saying, hey, there's ways to start introducing more structure. There's ways to start reasoning about these things so that when I really, really care about it, I can start to create more formal boundaries around it by isolating it, or I can start to create more determinism by describing that. But those are imperative coding concepts, and those only apply to the imperative parts of the system. The rest of it is still the thing that's actually driving most of the value creation is a stochastic system, and that is given to the vagaries of entropy. And there's a lot of sources of entropy. So I don't think you can ever give up on evals, right? Like I think you have to change the psychology of building and running these systems. The things that you can get it working, but it's not like a distributed system where you can reasonably assume it's just going to continue to work. You have to get it working, but then you have to have a continuous eval framework in place. So that to get it working, you have to run evals. To keep it working, you have to run evals. And you have to have the ability to constantly tune it because the behavior is going to change, right? Like this is sort of what is the SRE for AI systems, right? Like, and maybe SRE for AI systems is other AI systems, right? Like, I'm not saying that this has to be a human function, but you have to have the watchers, and something's gonna, it's not enough to just deploy it. It won't continue to run if you don't continue to watch it.
And then another interesting development that still seems fairly niche and hasn't gained a lot of adoption or even really proven out its overall capability is the idea of these large action models as opposed to the current transformer models, where the idea is that rather than them being for conversational purposes, their goal is to be able to take instruction and then make some sort of action on it. And I'm just wondering how you're seeing broadly the evolution of these generative models, the new architectural paradigms, and the interfaces that those models presume changing the types of tooling that we need to be thinking about, and whether MCP will be eventually obviated, if there will be other interfaces that we need to be able to support for maintaining context for different model architectures, etc.
Yeah, it is interesting, and it's something that I have certainly given some. Well, like I'm not an expert on kind of the evolution of model architectures. Like I do take the beta lesson pretty seriously, right? Like I think that at the end of the day, there's no amount of kind of like this is the danger. Like, and I think a lot of enterprises are really struggling with this, right? Like it feels kind of hopeless, right? Because you start a proof of concept on something. You think you can create value that's going to differentiate you versus your competition. You get to a certain point, and then you're just overwhelmed by the next frontier model comes out. Its capabilities are disproportionately different. Things are moving so quickly, and I think we certainly haven't seen asymptotic convergence around capabilities of the system yet. So what I kind of really focus on, and I think this kind of, I always describe this in two ways, right? Like there's the Emerald City and there's the yellow brick road, right? And we don't know what the Emerald City is going to look like yet. We haven't seen it. Like, we can see a glimmer in the horizon. We know it's going to be fantastic because, every signal, points that way. So the question is, how do we make progress in the meantime? And what are the set of things we can do? And like, I think of this as a kind of future-proofing exercise, right? I think there's these hard, immutable truths about bringing systems into existing environments, right? Like one hard immutable truth is that what is regulated will stay regulated, right? Like there may be ways to help you deal with regulatory oversight, but regulations tail technology by a pretty significant margin, and that regulatory landscape isn't going to change anytime soon. So there's a set of things that you just have to be able to do, right? Like you just have to be able to authenticate, authorize, assert policy, generate observability, auditability. You have to be able to track provenance of things. Like there's a bunch of sort of ooky enterprise things that need to be done. And I think that, as we see this disruption, like the slowest moving part of the disrupted landscape is the thing that touches your existing systems, right? Like you go talk to a bank and you ask them to describe their workflow. There's always a mainframe, like every time, right? Like if you haven't seen a mainframe yet, you just haven't asked the right questions. There's always a mainframe in there somewhere. Technology's fantastically slow moving because at the end of the day, a company is this weird enmeshed union of its people, its processes, and its technology. And you can't change just one of them, right? Like they all have to kind of change together. Like that is what is running the world right now. Like what's running the world isn't these models. It's the existing systems. Like if I want to get money out of a bank account, I'm not touching a model. I'm touching these existing systems. And so I think the safest place to innovate, well, not so much innovate, like invest, is like obviously, have access to these models, like figure out what they can do. But at the end of the day, you have to have this interface and it has to be controlled. And it has, like you have to be able to reason about it, right? Like if you're an organization, like I spent a lot of time talking to, grown up companies and, like, hey, we can't have these things NPX and store random shit off the internet. Maybe they'll eventually, do something, but we can't have them running unsupervised code that's touching production systems. Maybe one day we will. Maybe in 5 years we will, but that's not going to happen today. But what we can do today is put a boundary around it, start to reason about the identity so that, the action of this thing is showing up in its own context. We can reason about like auditability, traceability. We can start to, assert, controls around those pieces. And so look, 96% of the world's information is behind the firewall. You have to be able to access it and you have to have a pragmatic way. MCP might be it. Maybe it's not. Maybe we'll come up with some new cool thing, next year. But so that's thing one. Like you just have to unlock that in a way that's pragmatic. And I think investing in an MCP-based platform is the best way to do that right now. But the second thing is that sort of 96% plus the 4% of public domain knowledge only represents 0.0001% of the world's data, right? Like that's just knowledge. That's stuff that's been synthesized into human consumable kind of tokens. The rest of it is time series data, video streams, like all these other things. Like you're not going to want to inference on that. You probably can't inference on that. It doesn't even make any sense. So you are going to need systems that can start to translate that ocean of information that is not knowledge into something that you can actually start to feed into these systems. And so I do think that starting the journey with MCP is entirely logical because there's so much obvious value right now yes, the state of the art will change. It will be different in a year. It will be different in 5 years. But you will still need to authenticate, authorize, observe. You will still need to assert policy. You'll still need to do all of these things. Building your muscle on that now is sensible, because whatever new technology comes along, you will probably be able to reuse a lot of that. And if you make a platform investment in this space, the platform will evolve to keep up with it.
And digging now more into ToolHive and that platform question, what are some of the core capabilities and core ideals that you're focusing on with that as a means of building that foundational layer for this context engineering and context exposure to allow teams to be able to have a reliable means of being able to actually interface with that broad corpus of information that isn't already synthesized into knowledge?
Yeah. So, I mean, the way I think about it, and this is something that comes up in every conversation I have, like there's 4 constituent pieces that you need when you want to basically render I love the context engineering narrative. We call it just an MCP platform, but it's a context engineering platform. It's a platform that enables people to start building these next gen AI-enabled apps. Part 1 is secure runtime. And when I say secure runtime, I mean hey, fetch server is great. A lot of people just install the fetch server and you can access something. Do you really want one of these agents having unfettered access to every resource on your corporate internet that isn't behind the North system? Or do you want them to be able to access that using the user's auth? Probably not. So being able to just describe a runtime environment into which you can deploy a server with all of its associated tools, and then start to reason about that is pretty important. And so it always starts with that secure runtime. The second piece of it is this gateways are dime a dozen, but you do need a gateway technology, right? The way I think about this is you need a gateway not only as a way to a lot of gateway technologies are built around this ideal of hey, run all your it's like an API gateway, just run all of your servers through this API gateway, and you can now start to assert security, and you can deal with authentication, authorization, and you can have some basic policy assertion. I think that's the wrong path, right? What you really want is an aggregation endpoint that you can start to map and recontextualize. So when this tool is calling this system with this thing, these are the tool descriptions that map those kind of atomic units that are going to produce the best work. Here's an endpoint where I can start to apply semantic search, right? Hey, I've been using a frontier model. It's fine at tool selection, but it's killing me on inferencing costs. I want to kind of thunk down to a low model, but I don't want to have to reimagine my tools. I need semantic search. So that gateway then becomes a single endpoint with semantic search, the ability to start, driving a lot of the tuning and composition narrative for specific workflows or specific users or specific groups, based on some other configuration setting. And then the third piece of it is orchestration. You need to be able to start snapping these things together. Pushing orchestration into the model is very expensive, and it creates the possibility of entropy cascade, where you're asking something that's stochastic to do a set of relatively precise sequential tasks. You're either going to have a lot of redo, which generates token wastage because it's just trying and trying and trying, or you're going to get unpredictable results. So the ability to start describing structured orchestration and then transactional behavior. Hey, I want this thing to do this action, but I really can't afford it to, I'm issuing a refund. I really can't afford it to, mark this thing as issued a refund and then, do a financial disbursement. Those two things have to happen concurrently, and they're two different systems, right? So you need that sort of capability. So, I think of it as going beyond a gateway to a kind of virtual MCP construct. It's a way to start optimizing and rendering tools. And there's a lot of other things you can do in that space. We're working on things like context compression, other ways to start to do context augmentation. There's a lot of other systems that belong in that layer. And the third layer is the registry, right? So this is we've been working very closely with upstream communities, particularly around the registry specification, the registry implementation. But as you start to have MCP as a protocol, being able to start to describe, these are the set of servers that are available to your organization. Some of them can be run locally in a certain environment. Some of them can be run as a sort of heroic hosted system. There's lifecycle associated with that, and some of them are proxied because hey, there's some great SaaS-based MCP servers, but I want them all aggregated, and I need to be able to describe that. I need to be able to make sure that I let my organization know what can and can't be consumed and what's available right now. So the registry is an important part of that. And then the last piece of it is you have to generate a console, right? Hey, I'm a developer, I want these servers. Where do I go to actually start setting up that surface area? Where to go to start kind of tuning it for my workflow? Some of that will be driven by UI, but over time, most of that will just be driven through a meta MCP server, right? Where that just happens. Hey, I need a server to do something. Can you find me one? Sure, here it is. We can go from there. So those are the constituent pieces that we see a lot of demand for. That's what we've built with ToolHive.
Another interesting aspect of the tool equation is in particular when you're using these AI agents in a local context, particularly for software engineers, where things like Claude Code, Copilot CLI, Gemini CLI are the forefront in terms of usage, and they do have capacity to interact with MCP, but they also have your entire suite of command line tools available, as well as ad hoc and arbitrary tools to be able to bring in context, perform different actions. And I'm wondering how you think about that juxtaposition of MCP as a protocol for either curated or remote actions versus just having a suite of, hey, you can do whatever you want and figure it out as you go, as a means of kind of tool use.
It's interesting because, like, I always joke, like with developers, it's always safety third, right? Like, it's very hard to sell a developer on a safety first mindset because, like, really, developers love building, right? Like, they don't love locking down and hardening and all this sort of stuff. And you can certainly make good inroads, just in an interactive model with kind of Bash and whatnot. But I think this kind of these there's a set of environments where this becomes problematic. Like, one is, I mean, how often have you had, one of these things, RMRF, your file system, because you weren't kind of paying attention, right? And there are, like I said before, like the security stuff, people are getting shut down because at the end of the day, the cost of a security breach is dramatic. The embarrassment associated with this is dramatic. People are starting to, at least the people I speak to are getting authentically gun shy about, relatively unfettered, kind of root level access to whatever resources you want. Because, while you might have it in your head that you can watch this thing and make sure it doesn't do anything stupid, you're human. Like, that's a low dopamine task. You're just going to tune out. And sooner or later, it's going to do something that you're going to regret. So I think that kind of helping recognize that, but you have to provide an alternative that is just as useful. I think that's the key thing, right? Like, for a developer to actually embrace this stuff, the alternative needs to be as delightful and as capable, right? So you need to have a relatively robust set of tools. You need to start observing a set of things that they want and actually start to reason about delivering the tools. And this is something that is wonderful about open source. Like, this ecosystem will start to like the best way to tap into a lot of people is to start actually having an ecosystem emerge and start to formalize it. But there's also knowledge workers, right? Like, there's a lot of citizen developers out there, and God help the world when they start to, like a lot of organizations, cyber programs are built around the idea that, like, developers go through training, and now you have citizen developers that are basically, oh, I know how to do all this stuff, and that gets kind of even more dangerous. So I think one is, this will be naturally correcting as people start to just recognize that pace of exploitation is outpacing pace of spend, and the cost of exploitation is becoming a line item that you need to worry about as much as you're worrying about the actual spend on the systems. And then I think a lot of it's also just, it's nascent. Like, we haven't fully shown what this can do, right? Like, it's a curiosity, but until organizations or people or individuals start sitting down and asking hard questions around, like, what are the actual nouns and verbs that dominate my life? How do I start to generate tools? And I'm not saying I'm going to write the tools. Like, it's entirely reasonable to have an agent start to build those tools based on the known set of nouns and verbs. And that code can then be reasoned about, hardened, isolated, secured, and published and reused inside an organization. So that's the sort of, I do agree. I think most developers aren't attracted to, anything that's going to kind of, inhibit their ability to vibe code their way into productivity. But I do think that there are options that will initially satisfy, but eventually delight developers, give them tools that they can use to kind of radically improve their life, but also not get hurt.
In that context of security, to your point, developers always put it last because we'll figure it out later. In terms of what you're doing with ToolHive, obviously there is authentication at the access layer, but I think another interesting piece that you're bringing in is that question of how do we actually expose credentials to the MCP servers themselves, because that's also another piece that in many of the MCP servers is left as an exercise to the reader. And I'm wondering if you can just talk to some of the ways that you're thinking about the overall ecosystem of MCP.
Yeah, I mean, it's like, this is where we already started the journey. It's like, look, I'm a grown up. I want to use these things. I'm not going to have API key written in plain text on my system where an agent can read it. Like it's just not going to happen, right? And so, being able to start using, we started with local, kind of serving people with a local system, being able to use, one of the locally integrated, kind of key chains, like, one password or the Apple integrated, system. So you write your tokens in there and it just gets mapped into the files by system. Made a ton of sense. And so, we certainly started with that, but the place where it gets really interesting is on the server side, right? So when you're starting to look at, hey, I've got a set of clients and they want to start connecting to the server, the MCP specification is pretty good at the client server auth flow. But the exercise of saying, here's a set of patterns that enable you to, reason about, server to backend server, auth it's an exercise to the reader, right? So, I know like friends at Okta have been doing, quite a lot of work in the space. The Intra people are doing a lot of work in space. There are conversations happening in the community, but you have to have a reference implementation, right? So what we basically, did is said, what are the 4 or 5 common patterns that people have? Like, hey, you want to use an OAuth, kind of credential. Like, how do you do a token exchange so that you can, move from, a token that is, scoped for everything a user can do to a token that's scoped to a specific task? And like, what does that look like in a canonical way? And how do you implement that without having to redo this for every MCP server that you're building? Hey, I want to use a durable credential to go access a database. How do I inject that conditionally, and how do I set policy around that? So we've put a lot of time and thought into the authentication and authorization space, but we're also just working with a lot of partners, right? Like it's like, hey, you're not going to want to deploy a new identity provider. That's kind of there's a reason why permissionless security and zero trust. There's been a lot of adoption difficulties in enterprise because enterprises are living with what they have. It's difficult to unless you're entirely greenfield to adopt these types of patterns. So a lot of what we've been trying to do is just figure out how to make it work with what you have, but recognizing that there has to be a space for something that's agents have to have their own identity. It's not an OIDC credential. It's not a service account. It's a delegated credential that has a certain set of attributes. You can kind of make it fit into some of these systems, but eventually we'll figure out what that looks like, and we'll make sure that we can kind of support that over time. And then the other place we look at is just this should be obvious from a security perspective. You need to be able to do kind of malicious prompt detection. You want to make sure that you do PI data reduction. There's a bunch of things. We've made sure that the system is kind of sufficiently principled so you can just snap in whatever your favorite is. And over time, ToolHive will come with a lot of batteries included options for those pieces as well.
And as you have been coming to grips with the current state of the ecosystem, understanding the usage patterns and the opportunities, and building out ToolHive to get in front of people, what are some of the most interesting or innovative or unexpected ways that you're seeing that toolkit used, or just MCP more broadly?
It's interesting. Like it's this caught me off guard. We did this, and we've worked with other people that have done the same thing. It was kind of a silly thing. We wanted to build a knowledge server, and basically what I'm saying by that is like, hey, a lot of people are buying Glean, or they're buying these kind of first class systems that they integrate with all their systems. And I set my team an exercise of like, what would it take to just build one of our own? Like what would this look like? And it turns out it was actually surprisingly easy. We just build an agent that runs it. We go and take all of the content, we chunk it. We had to do a bunch of tuning because the quanta when you're chunking Discord messages versus kind of Google Docs to make sure that the semantic relevance showing through was surprising. But having MCP based knowledge server endpoint, we just call it the knowledge server, and you can integrate into all your tools. And you can ask it questions, and it can basically see, everything that's within your, the kind of public domain. It was a complete game changer. It's just shockingly useful. Like it's just wonderful to be able. Oh, by the way, what is this developer working on? Or oh, by the way, what are the top? Has this been mentioned in Discord? I haven't seen anything on it. Oh, yes, it has. Right. So that's just sort of immediate like unlock of institutional knowledge through a relatively simple to implement service. So we built this thing in a few weeks. And it's just shockingly useful, right? Like it just it changes how I work. It's changed how everyone in the company works. And as we started to talk to other people, that becomes like sort of an anchor. The ability to sort of redefine how support works. Just like build a knowledge server and expose this as an endpoint. And now like these things suddenly they just have rich access to kind of precise semantics. I just didn't expect that. Like it's just one of these things I thought it would be a huge Herculean lift. It turns out that a couple of engineers knocked out something just damn useful in a couple of weeks, and it blew my mind.
And as you have been building in this space and growing a company around ToolHive and this overall space of empowering teams to build these AI native applications, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I think the biggest challenge that organizations face is, and I mean, and this should be obvious to I think anyone who's worked in the space for a while, but it's not enough to just start to expose tools, right? Like you have to really think. Like I've seen this with a lot of folks where like they're like, okay, we're building a system, like, and we like here's the problem. Like Cursor is the same dumb intern every day, right? Like it's like they're incredibly enthusiastic, they're incredibly prolific, but they know nothing, right? And like for an enterprise that wants to work, like they just can't npx install these random tools. They just can't use those integrations. And so they start, kind of working on the assumption around like, okay, well, if we just created a server that made this doc available, that doc is the specification. If we just did this and we just did that, everything would kind of work. And what's happening is this, it's sort of, they're seeing kind of incrementalism, but they're not necessarily seeing a sea change, right? Like it's, you kind of have to start rethinking the SDLC, and you have to rethink like where value engineering is happening. And I think the fact that organizations are bringing a relatively kind of traditional mindset to this and aren't taking the time to understand what problem are you solving, where are the boundaries, like let's run some very, very fast experiments. Let's not assume that just kind of rendering all these endpoints as tools is fundamentally going to change the workflow. Like let's actually start by trying to understand what we're trying to accomplish and work back from like, well, what do we need the model to know, not just have access to? What do we need to do to start to contextualize this? Because it's interesting to see how you get these kind of like people work with these tools over time, and like there's this weird thing that engineers do where they start to like have these almost ceremonial set of activities, and what they're effectively doing is do this first because then it knows what packages, and now they're effectively manually loading the context window with by performing things in a certain order. It's getting to the point where like they don't necessarily even realize they're doing it, but they know that it works. And so there's a sort of process of kind of implicit discovery of how to render context in a way that actually completes a task, but it's not being written down or formalized or reasoned about in a first class way. And so I think you kind of have to start with an experimental mindset where it's just like, look, let's just get these things, let's just put it in a controlled environment, get them working, try it, see what happens, play, and then ask the question, okay, what's working, but why is it working now? And what can we start to do to kind of work back from that to actually start describing the tools that will get us into that state?
And for people who are interested in expanding their investment in MCP as a core capability, what are the situations where you would advise against using ToolHive specifically?
That's a great question. I would say if you don't know what MCP is, don't use ToolHive, right? Like if you're not at a point where like if you don't know what problem you're trying to solve is, like I can't help you, right? Like it's this is a system that's really it's solving two problems, right? Like it's solving the problem of control for a real world company, and it's solving the problem of scale. Like when you want to go from 1 to 10 to 100 to 1,000 to 10,000 servers, it's a good system for that. If you haven't yet tried to just use the SaaS-based endpoints and experiment, if you're not convinced that there's something there, ToolHive is probably not the right starting point, right? Like it's this is a tool that is it's ready for teams that are invested in building cloud native applications that want to unlock first party data in addition to other sort of data. It requires a fair bit of operational lift. This is not a sort of an incredibly simple turnkey, just turn on and go kind of system. This is like, no, I'm serious about this stuff and I need a platform to do it, and I want to operationalize it, and I have to reason about authentication and authorization. And yeah, I know I want to do this. Maybe I haven't figured it out perfectly, but at least know what MCP does. And I know what I want to start exposing. I have a theory around what my first projects are. ToolHive's a great option. But, I would definitely start by, hey, just turn on the integrations in, like all of these systems have native integrations. There's a lot of SaaS-based endpoints out there. Start there, see how far that gets you. If you're still if you see the value, but you don't know how to fully unlock it, if you get to the point where you like it, but you can't use it because you're an enterprise, and if you're interested in like, okay, how do I go beyond that and I want to start building, in earnest, and I want to start really reasoning about how to not just, provide a tool, but deliver a tool that works for this agent all the time, that has this kind of rigorous eval framework, that has this kind of tuned behavior, that, I've got a lot of tools. I need to start, reasoning about context pollution. Hey, I want to start driving, kind of context compression. There's a variety of these things I want to do. Come talk to us.
And as you continue to build and invest in and grow ToolHive and expand the overall set of offerings from Stacklok, what are some of the things you have planned for the near to medium term, or any particular problem areas you're excited to explore?
Yeah, there's a lot of things that we're interested in. I think we've got the core of the platform out there. Oh, by the way, it's an Apache 2 open source project, so it's Stacklok, but it's also Red Hat and a variety of other industry players are starting to participate in it. We've been very happy and excited to work with Red Hat. I should mention them here. They've put a fair number of engineers, and we actually have maintainers from Red Hat on it. So Red Hat will have their own theory around where this runtime goes. But for us, it's about kind of hardening the platform, like, getting to the point where it has, like I'm a Kubernetes guy, right? So when I say platform, I have a very specific taste around what a platform should look like, right? So, common API based interface, well factored, well structured, common naming conventions. So I'd say, thing one is, we're working very hard on the platformification of the system. So it looks and feels like an actual context platform, or a context engineering platform, or an MCP platform, whatever you want to call it. The second thing is, obviously we want to continue to enrich the capabilities at every level. So right now, secure runtime, we've basically built out the proxy layer, the gateway layer. We've put a lot of the VMC pieces, the VMCP, the virtual MCP constructs in there. We'll continue to put a lot of effort into that. So, enriching the orchestration systems, enriching the ability to support transactional semantics, layering in and making sure that the pipeline architecture supports capabilities like PI redaction, kind of turnkey, prompt and resource security. So there's a lot of work that needs to happen in that space. The registry is, I think we were the first people to have an upstream compatible registry, because we actually wrote most of the upstream, or not most of it, but wrote a decent portion of the upstream registry implementation for the recent release. We certainly contributed a lot, as that piece was out there. So, the registry is there, but we'll continue to harden it. And there'll be a lot of enterprise 101s associated with that. We've worked with the community to make sure that there's, kind of extensibility pieces in there, so you can start to get attestation. And, if you need to have signed images and you want to start reasoning about this thing flowing through, a more rigorous SDLC, those pieces are in place. So we'll continue to invest in that. But the place where I'm most passionate about is really the, what we call the cloud console, right? Like the ability to provide that interface where, like right now, hey, just, wire in the VMCP thing, and then people just, platform engineers will just deliver tools and you can use them. But we need to create that self-service experience, so that for developers and citizen coders, and for people that are, I say citizen coder, like everyone's going to be a citizen coder at some point, right? How do you actually start to describe your work in a way that's more natural? How do you actually start to participate in defining that interface in a much more kind of natural way, both through a kind of, AI native experience, so that you can interact with the model and it will actually support a lot of that work for you, but also potentially, having the right visualization. So I want to make that system an AI native application itself, right? So it's consumable through an MCP endpoint, but then as you start to have like web app, like a web MCP type, modularity, so you can actually start to have a really great experience when interacting with it. That's going to be a big part of our focus for the next little while.
And one thing, too, that I saw just recently from the folks at Sentry is they're working on actually making their MCP server be its own little agent, where rather than exposing all of the tools, it has an agent that takes the request and then determines which of the tools it knows about to then expose to your agent. I'm wondering what your thoughts are on some of that pattern as well.
Yeah, I mean, we like that pattern. It's it's the sort of, we started with just relatively simple semantic search. The implementation that we have, that this is really just to deal with the tool pollution problem. But there is this other piece which is very interesting, and we certainly spend a lot of time talking about it, which is like what is the how do you acquire privileges for a task, right? Like, because a lot of these agentic tasks, you don't know what resources they have to access a priori, right? So you don't know what they're actually going to do. You don't necessarily want to give them unfettered access to everything. So there's a human in the loop process initially, but eventually there will be kind of agents watching agents, and reasoning about a lot of these classes of decisions. I don't know where it's going to go. It's like I said earlier in this conversation, like regulation and policy trails the state of the art by a pretty large amount. So I think, for a lot of systems, there will necessarily be, for some class of work, there will have to be human supervision for a while. But I do like that pattern. I think it's very interesting. And, we'll as the kind of authentication authorization systems start to kind of snap into focus, we will certainly be looking at some of those patterns.
Are there any other aspects of the work that you're doing on ToolHive, at Stacklok, anything about the MCP ecosystem more broadly that we didn't discuss yet that you would like to cover before we close out the show?
We covered a lot of ground. This is really great.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I would just like to get your perspective on what you see as being the biggest gaps in the tooling, technology, or human training that's available for AI systems today.
Oh, it's skills, right? Like it's just the talent necessary to kind of take this. It's the mindset shift where it's not about what the agent has access to, it's about what the agent knows. Like it's how it's contextualized. It takes time. Like people will build that expertise, but it's expensive to do so. So I think the biggest gap there is skills. And we provide forward deployed engineering capabilities, and that's the best way to kind of translate the skills. And so I really think of it as a bootstrapping problem, right? Because you need to be able to transfer skills into an organization. So we don't sell the product without FDE support, because we know that's what's required to get people to succeed. But it's this bootstrapping. You need to do that enough to get to the point where the organization generates its own awareness, and then you need to start providing the agents that actually are able to perform those tasks. But it's a cold start problem. It's a bootstrapping problem, right? Like you can't deploy the agents until the organization has the capabilities to run them. You can't necessarily describe the agents until you spend enough time working with the organization to figure out what they're trying to do. And so it all comes back to that activation energy problem, where you just have to have someone on call that knows what this looks like, that's done this before, because it will reduce your time to outcome by orders of magnitude. Like it's not hard to go from nothing to a running version of ToolHive with a well-formed set of MCP servers in place. But getting to the point where those are actually tuned to workflow and are generating results and are reducing token consumption and are improving agentic task completion requires like a different way of thinking. And so that's always the hardest problem. It's just that 0 to 1. The platform's easy. We'll deliver that, but it's how you use it that requires this kind of sort of skills that organizations are struggling with right now.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on ToolHive and in standardizing and simplifying some of this overall ecosystem of MCP and context engineering for people who are trying to build these AI native applications. It's definitely a very important set of capabilities, and I appreciate all of the time and energy you're putting into that, and I hope you enjoy the rest of your day.
Likewise. Thank you so much.
Thank you for listening. Don't forget to check out our other shows. The Data Engineering Podcast covers the latest on modern data management, and podcast.init covers the Python language, its community, and the innovative ways it is being used. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at aiengineeringpodcast.com with your story.